Alright guys, I'm gonna be performing a capacity test from the new cells. This cell has been sent by a forum member and is claimed as a JP40. However, the cell has code name apparently LT, let me see where it is, LT21700. As I mentioned, claim it as a JP40. Everything, there's some evidence that is a JP40. I cannot tell you 100% sure, but I mean, based on the information and all that, it look like, have in the negative side, have the logo and all that. So I'm gonna explain what I'm doing in this procedure, right? That in this test, I spot weld the cell with 0.3 pure copper, and I welded with nickel sandwich using copper terminals, and this is 8-gauge wire using a XT90 connector, and I'm using this DP24 EW tester with modules all the way to 3000 watts. Not required, but that's what I have. And I'm gonna be making a full capacity load from my tester, which is gonna be 40 amps continuously on this cell. The cell claims to be able to do 45 amps continuously, and I'm maintaining a very low temperature. So I test that already. I'm gonna make this video to evidence that the cells they claim to have 2.6 ohms, milliohms in internal resistance, which is I have to say is true. I have it tested, and I mean, it's impressive. And I'm gonna be using, as I mentioned, this is gonna be my load. I'm gonna do it in 40 amps. I'm monitoring the temperature with the probe in the equipment, but at the same time I'm using a Fluke 87V5, which is a very reliable and popular tester. And I'm gonna be monitoring as well with my thermal camera, which is a unit UTI 260B. I calibrated as close as I can with the meter. However, because the reflection in the cell and all that, it can be margin of error. So I trust more, obviously, the Fluke. And we are gonna be starting now. I have this equipment connected, as you see, by USB to my computer. Sorry for the mess. And I'm gonna be recording all the data. Right now the cell, if you see, have 4.2 volts currently, so it's in full state of charge. I'm gonna be starting the discharging 33 because I don't want to blow my fuse. And once it's starting the first 5 seconds, I'm gonna increase that to 40 amps, and I leave it until the cell is completely depleted to 2.5 volts. And we're gonna be recording the results. So I'm ready to start pretty much. And let me get ready the option to change the amps to 40 once this starts, because again, I have a problem that if I start like that with a burst, it will blow the fuse. All right, currently, if you see, the temperature is 24.2. On the meter, I calibrated as well on the meter, which shows 24.5. Let's see, the other one, 24.2, is a little bit off, but it's good enough. All right, let me make sure data is clear. Start discharging, and let's wait a little bit. And I'm increasing the 40. Let's keep going, monitoring now. The temperature is gonna keep going raising, that's normal. Let's see in the thermal camera how everything looks like. We have the highest 30 in the camera. In the fluke 28 is good enough for me. If you see these cables, the front cables are 8 gauge. This one back, they're 10 gauge. So that's why you see those cables a little bit more hot. That's normal. Normally I don't use 8 gauge, but because this is a super high, let me do something. Sorry for the noise in the meter. I should shut it off. Let me do it now quickly. Otherwise we're gonna be crazy with this. All right. 34. And here we have 39. I mean, which is, well, 20. You see the numbers. 40 amps continuously right now. This is at real time. I'm not speeding up this video. The cell, I guess, is doing great. Look at those numbers. I have to mention that I try the same thing with moly cells, which I have brand new ones here, P42A, and at 40 amps I have to stop the test because it reached more than 95 degrees. So far we have 40 here. Don't have too much voltage drop. This is going good. You can see the numbers here in the computer. I'm gonna share this information, this data sheet. So it's pulling 40 amps, 39.9, 131 watts currently. Temperature show here 43.7. Let's see how accurate is this. It's gonna be 44. 44.1 is pretty accurate. I'm happy with that. Let's see how this is going. It's going good. volts. Wow, only 46 so far. That's great performance from the cell. 40, this is 40 and continuously, remember. Just want to make sure you're not showing all the connections. That's what they have. The probe connected. They're taping. I set the system to stop 2.5 volts. However, I noticed this cell drops very quickly after touch 3 volts. You're gonna notice that voltage drop very quickly. monitor that temperature. 53.9, that's great. Wow, so far I have 3.77 and 3.8 amp hour. This cell is rated to 4 amps hour. At 40 amps, it's impressive. We almost have those 4 amps hours, 4 amp hours. Look at that. At 40 amps, I never seen a cell doing that. It's just stop. That's the result. 4 amps hour. Impressive. Almost 4.1. That was in 6 minutes depleted. This is really good. And the maximum, let's see, recorded maximum 59.5, below 60, minimum average. And right now, that's gonna start decreasing now. Well, you have it. That's the cell. Well, I cannot assure it's a JP40 because here, well, have another code name, but apparently it is. I mean, a JP40. I can tell it's a beast of cell. Everything point that is, well, use of the numbers. I'm gonna share that. All right, have a good one.